And starting the broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and thank you for attending our Getting Started with TracePro webinar. Today's presenter will be Dave Jacobson, our Technical Senior Application Engineer here at Lambda, and I'll be your moderator. This is Mike Govin, the VP of Sales and Marketing for Lambda Research. And with that, Dave, take it away.
Thanks, Mike. Hello everyone, and welcome to today's webinar. As from the previous slide, the topic today is going to be getting started with TracePro. Before we get going, just a little quick note about the format. The presentation will probably last about 25 to 30 minutes. Based on the morning session, it might go a few minutes longer than that. And any time during the session today, please feel free to submit your questions using the question box in the GoToWebinar control panel. And we'll take a look at all questions at the end of the webinar. A couple additional resources I always like to mention before we start the webinar. First is all of our past TracePro webinars, and we keep copies of these on our website in the webinar section. In addition, we have tutorial videos and printed or written tutorials that you can also download from the appropriate sections on the website. And also on our website, you can find information on our upcoming TracePro training classes. And on that note, our next two TracePro training classes are coming up here very soon. The first is next week in Jena, Germany. We're going to have a 2-day course on an introduction to TracePro starting Tuesday, March 8th. And then we'll have a 2-day course on optimization using TracePro, and that'll run March 10th and 11th. So those classes will run Tuesday through Friday in Jena, Germany. And then following that, a couple weeks later, we're going to have training here at our Littleton headquarters, Littleton, Massachusetts. And again, the same two courses, 2 days on an introduction to TracePro and 2 days on an optimization with TracePro course. And that's starting March 22nd. So anybody interested in that, either of these courses, please feel free to contact us and we can get you some additional information. Also, another quick note, TracePro 7.7.1 was released on February 26th, so last week, and we encourage all customers with current maintenance and support agreements to download the new release. And you can actually check for this new release right in TracePro. If you have a newer release of TracePro, just go to Help and then check for updates, and it'll automatically download and install the new version. So with that out of the way, let's get started on today's topic. And we're going to look at this is an introductory webinar to TracePro. And it's about getting started with TracePro and how to get up to speed and running quickly. The agenda for the webinar is going to be, we'll do a quick introduction here. And then we're going to go through two examples. The first is a luminaire example, and we'll look at importing geometry from a CAD program, creating some additional geometry in TracePro, applying properties, defining sources, running the ray trace, and then analyzing the results. After that, we're going to also take a quick look at a light guide or a backlight example. And the main focus in that example is I want to show a little bit about using ray files for LED sources in the model. And then we'll wrap it up with a question and answer session at the end. And again, feel free at any point during the webinar to submit any questions you may have. So this is the typical workflow in TracePro. Create the geometry, apply properties, define sources, run the ray trace, and analyze the results. And you can do all of this right in TracePro itself. Now, as an alternative workflow, you could work with a CAD program, such as SolidWorks, CATIA, ProEngineer, Inventor, or really any CAD program. Create the geometry in that CAD program, and then export it as a STEP, an SAT, or an IGES file, or using the TracePro Bridge for SolidWorks, an OML file. Export that to TracePro, and then in TracePro, apply the properties, define sources, run the ray trace, and analyze the results. If you're working with SolidWorks, we have the option where we have a program called the TracePro Bridge for SolidWorks, which would then let you in SolidWorks create the geometry, apply all of your optical properties and define your sources, and save those as part of the SolidWorks model. And you could then export a TracePro OML file from SolidWorks to run the ray trace and analyze the results in TracePro. And lastly, we could use the TracePro interactive optimizers, the 2D and 3D interactive optimizers, right in TracePro itself to create additional geometry, and then use TracePro to apply the properties, define sources, run the ray trace, analyze the results. But in this case now, we can also use the optimizers to automatically change that geometry to try to meet a user-defined goal, such as uniformity or illumination pattern or angular distribution. So another way of working with TracePro. And before we start our example here, just want to make a mention about the menu structure in TracePro. And it's a logical and organized menu structure where all of the relevant items are grouped together. And then they also tend to follow a logical order to help you facilitate an organized workflow. So just looking at the menu structure, it goes in a flow from left to right, where we can import files, we can edit, we can create geometry, we can then define the properties, run the ray trace, and then optimize or analyze the results. So it creates this logical workflow using the menu structure. So let's take a look at our first example. And I'm going to walk through some slides here, and then I'll jump over to TracePro and do a live demonstration of setting up this model and running a ray trace and getting some results. So this example we're going to look at today is a desk lamp model. In this case, the model is built in SolidWorks. And this is a finished version of the model showing the 3D irradiance illuminance map right on a surface in the TracePro model. So the steps to this process, once we've brought the model into TracePro, we'll go through and we'll apply some surface properties to the lamp parts. We'll apply a surface property, in this case a mirror property, to the reflector itself. Apply a material property to the window that goes in front of the reflector. We'll use a surface source property in this example to define the 4 LEDs that act as the light sources. We'll also use TracePro to add in a target object, for example, a desktop or a work surface. And then we will apply a surface property to that target. In this case, we'll apply a perfect absorber so that all light that hits that surface stops and is absorbed there. In addition, I'll show you quickly that you can go in and apply color to the objects. And this can be used to improve the visual appearance of the model. So if you're putting together a report or a marketing brochure, you can very easily add color to make the model just look a little more realistic and a little more appealing. I'll also mention as we're setting this up, this is a visual application. So we're going to change our analysis units in TracePro to photometric. So we can look at visible light units, things such as lux and lumens and candela. And I'll show you when we get ready to set up the ray trace where you can make those changes. Then we're going to run the ray trace. And then we'll look at some of the results. In this case, here's an illuminance map on that desktop, which I've named receiver here. We will look at a candela plot, so the angular distribution of the light that's hitting that surface. We can also look at the 3D illuminance plot. And the 3D illuminance plot is nice because it shows you the distribution of light directly on the surfaces in the model. And it also allows you to select multiple surfaces. So here we have the desktop selected, as well as some of the parts of the lamp as well. And we'll go through all these steps here. So let's actually jump over there and we'll go do that now. So I'm going to start off, just a quick look. Here's the model in SolidWorks. And from SolidWorks, I could export this out as an SAT file, also called ACIS, a STEP, or an IGES file, or also, since I have the TracePro bridge installed on my computer, I could export a TracePro OML file. Now in TracePro, I can go to File, Open, and for example, let's say I change my file type to SAT. Here's that assembly in an SAT file format. I can click Open. It's telling me I already have that file here, so I'm going to just click No and rename it. And here's that object right there, that model, right into TracePro. Also, I could open up this one here, is the version I saved from SolidWorks using the TracePro bridge. And the one advantage here is that when I saved it as a TracePro file, it maintained the object names. So it's one less step that I had to do. I didn't have to go back in here and figure out which each of these parts are. So if you remember back to the steps we're going to go through, the next step is to start applying properties. And first thing I'm going to do is the parts that actually make up the lamp. I'm going to select those here. And I'm just holding down the Control key and clicking on the different parts here. And you can see they highlighted a different color in the model. I'm going to do a right click and go to Properties. And I'm going to choose a surface property. And in the default catalog here, I'm going to scroll down and I'm going to choose black paint. So the finish on this lamp is a black paint or a black coating of some type. So I click Apply. If I come back to one of these objects, say the base, expand it, we can see here, I applied black plastic by mistake, so I'm going to go back to Properties and choose black paint. So now if I expand any of these items, we can see it says black paint here is the property type. And since I applied it to the object, in this case, by selecting the top object level, it applies the same property to all surfaces of that object. If I was only interested in applying a property to specific surfaces, I could come in here and then select the surfaces I wanted. Say, for example, use the surface select, this surface here, it highlights here, and I could change that property if I wanted to. Okay, next step, I'm just going to rotate the model here using the orbit tool. I'm going to pick the glass diffuser or the window. I'm going to do a right click, go to Properties, and I'm going to choose Material this time. And I want to make this window out of shot. It's one of the standard catalogs in TracePro, shot. I'm going to scroll down to BK7 and apply that. And the next step, the two things I want to apply is the property to the mirror or to the reflector, and then the LED properties. And the problem is that they're hidden behind this piece of glass. So I'm going to do a right click and choose Deselect Display Object. Now that doesn't remove it from the ray trace, it just turns off the display. So I can zoom in here now, and here's my reflector. I'm going to do a right click, go to Properties, and once again I'm going to choose Surface. And for this example, in the default catalog, I'm going to scroll down and choose Mirror, and then click Apply. Once again, if I come over here, any surface I can open it and expand and see the property's been applied. Now this model, I'm using 4 LEDs here, so I have 4 little objects to represent the LEDs. And I'm going to come in and I'm going to use this Surface Select tool here. And notice if I hover on an icon, a little description of what it is pops up. So Select Surface. So I'm going to choose that, hold down the Control key, and select the emitting surface of each one of these LED models. Then I can right-click, choose Properties. And for this, I'm going to choose a surface source property. So choose Surface Source. And if I select for the emission type source property, that gives me access to all of the catalogs of LED surface source properties that are preloaded in TracePro. And for this example, I'm going to use the Cree X lamp. I go down here to the Cree X lamp catalog, and we're going to select an XPE white. And I'll choose the middle one, 3700 to 5000 Kelvin. It's a neutral white LED. Select that. I can set the number of rays I want to trace. And in this case, oops. Oh, that's interesting. I apologize for that. It's the fun of doing live demos. So I'm just going to open that up again quickly here. Oops, I want the other one. And I will quickly go through the steps we just did. Reapply the black paint property. Okay. The glass is going to have a material property. Shot BK7 again. I'll turn that off. Zoom in. The reflector can have the, once again, a surface property of a mirror. We'll zoom in one more time. Right-click in Properties, Surface Source. Cree X lamp again. And as you can see, once you get used to it, it doesn't take long to go through and set up a model. Now I'm actually going to go in here. I'm going to change my wavelength type to what's called calculated wavelengths. And this will let me define a range of wavelengths that I want to use for this example. And I know this is a white LED, so I want to use the range of visible light. So I'm going to enter in 0.4 microns. Click OK or Add. Then 0.75, Add. And now I have 3 bands of wavelengths, 0 to 0.4 microns, 0.4 to 0.75 microns, and 0.75 to infinity. And I really want, in this visible range, 0.4 to 0.75, I want to have 10 wavelengths. So I'm just going to click that. I just put in 10 here in this column where it says number sign or pound include, click somewhere else, and it automatically fills in those wavelengths. And it automatically weights the flux at each of those wavelengths depending on the spectrum that's defined as part of the surface source property. Also, if you want to add new surface source properties, say there's an LED that's not in the database, we have a utility in TracePro called the Surface Source Property Generator utility that will let you very quickly add new properties using the graphs that are typically found in an LED datasheet. You simply cut and paste the graphs into the utility and then click along the curves to trace them and then generate the property from there. And lastly, I'm going to set my number of wavelengths, my number of rays. I'm going to trace 25,000 rays per LED. Click Apply. Close this out. Now the last step I want to do before I look at the results, first I'm just going to right click and choose Collapse All. And I'm going to go to turn the display of that window back on. I'm going to go to View, Display All. Last thing I want to do is I want to add in a desktop or a target surface where I can see the rays and see the illumination pattern. So I'm going to use TracePro to add that in. I'm going to go to Geometry, Primitive Solid, and I'm going to use a block. I'm going to give it the name Target, and its size is going to be 1,000 millimeters, so 1 meter in X and Z, 1 millimeter thick, and its position is X is 0, Y is minus 170 millimeters, and Z is minus 440 millimeters. And then click Insert. The way I found those positions, if I hover my cursor at any spot here, I can look down in the lower right corner and see what the coordinates of that cursor are. So just looking at it, I could see there was roughly minus 170 by minus 440 in Y and Z coordinates. So a very quick, easy way to see where you are in TracePro. On this object, I'm going to use the Surface Select tool here. Make the window just a bit bigger. And use the Surface Select and click on the top surface. And over here, it tells me that's Surface 4. And I'm going to rename it. I just clicked on it, opens up a little editing box here. I can type in a new name. I called it Receiver. And I'm going to right-click on that, choose Properties, and I'm going to apply a Perfect Absorber property to that. And the Perfect Absorber property is just a 100% absorbing property. So all light that hits that surface stops there. And lastly, before I start the ray trace, I want to change my analysis units. I want my results to be in lumens and lux and candela, units of visible light. So I'm going to go up to Ray Trace Options. And here in the Options tab, I'm going to change over to photometric and then click Apply. And don't worry if you forget to do this before you run the ray trace. If you want to use photometric units, even after you've run the ray trace, you can come back here to the ray trace options and toggle between photometric and radiometric units and see the results change without having to rerun the ray trace each time. If anybody is interested in a bit of a refresher course on radiometry and photometry, what the different units mean, especially how they apply to the different tools in TracePro, we do have a webinar in our webinar section on the website that talks about and does a review of radiometry and photometry. So I'd encourage you to check that out. And now I'm going to run the ray trace. Starting, if anybody here is using a slightly older version of TracePro, this is TracePro 7.7 right now. One new feature is when you start the ray trace, it's going to let you choose between analysis and simulation mode. And a quick refresher on that, in analysis mode, the results are saved on every surface in the model. So we could then click on any surface, see things like the irradiance maps or the candela plots. The downside is it can be very memory intensive. And it's very easy to run out of RAM sometimes. Simulation mode would allow you to define an exit surface or the surface where you want to save the results. Say this surface named Receiver. We would then define it as an exit surface. And when you run the ray trace, it will only save the results on that surface. And it also saves those results to the hard drive instead of RAM. Now, the limitation there is that you're only able to look at irradiance maps on surfaces that you've defined as exit surfaces. Also, it doesn't show the rays. So my normal mode of operation is I start out a project, I'll use analysis mode. Then once I'm getting further along and I need to trace more rays, then I'll switch to simulation mode. But at that point, I usually know what surfaces I'm looking for results on. So for this, I'm going to stay in analysis mode. Just click OK. And now it's going to go through. It's auditing the geometry. This does take a few seconds here. The reflector shape in this model is a somewhat complex surface, sort of dimpled reflector. So it takes a little bit of time there. And now we're going to run through the ray trace. I'm tracing 100,000 rays here. It's not a large number of rays, but due to the sort of the complexity, there is an option in TracePro for what's called voxels. And voxels are the way TracePro divides up the space. And right now I'm using a setting called uniform voxels. And this is up in the ray trace options menu. I could speed this ray trace up by switching to what's called octree voxels, which concentrates these 3D pixels or voxels, more of them around the objects and fewer of them in empty space. And I know from experience with this model, changing to octree would speed up the ray trace probably by a factor of 3 or 4. The downside is it takes longer to go through that auditing process that we just started with. And I didn't do that on this case just because of the small number of rays, that it actually takes longer, even though the ray trace is much faster. The auditing process with this small of a number of rays made that the longer way. But if I was tracing more rays, I would definitely switch to octree. And if you look at another webinar we have called LED Luminaire Analysis, a start to finish demonstration, it goes into more detail about that and shows some examples of the time savings that's available using octree. Okay, so here's the results. Quick reminder to people that may not know it or may have forgotten, the color of the rays represent the flux or the power of the rays. So red rays are, when the rays start out with 100% flux, they're red. When the flux drops below 66.6% of the initial value, they're green. And then when it drops below 33.3% of the initial value, they're blue. So you can get a feel for like sort of high, medium, and low powered rays just by the color. I can clean this up a little bit. Again, I have the surface that's facing of the target that's facing the lamp selected. I can go to Analysis, Ray Sorting, and I could then choose Selected Surface for the sort type and click Update. Now it's only going to show me the rays that are actually hitting my target surface. So I get a little better visual representation of what's happening. We actually see there's some rays here that are bouncing off parts of the lamp and then hitting the target. First thing I want to look at here is what's the distribution of light. And I can go to Analysis and then choose Irradiance Illuminance Maps. The default setting here is a grayscale. Notice that our units are in lux, and then down here we have lumens as well. So this is going to be, this is the setting that's determined by the analysis units. If I had left it at radiometric, my units here would have been watts per meter squared and watts. But I can change the look of this. I can go right-click, choose the options. And for example, I could turn on smoothing, change my color palette to a color rainbow on black, and increase the number of levels. And look at it that way. I could look at a relief plot, so it's in 3 dimensions. We could turn on profiles, and these are all in the options menu. Now profiles show the distribution across these crosshairs here, so as I move this around, we can see that distribution there, both the horizontal and vertical. In addition, there's options here. Instead of showing irradiance values, we could look at CIE values. So wherever you hover your cursor, you'll see the CCT value over here. And this is somewhat noisy plot. We really haven't traced enough rays. It's around 3,800, 4,000 Kelvin, which falls in line with the LED spec was 3,700 to 5,000 Kelvin. There's also an option for true color. So you can start to get a feel for what it looks like to an observer. Switch back to irradiance here. One last thing I wanted to mention here is down the bottom is some additional information. For example, we can see the total flux on this is 1155 lumens. And then this next value is flux divided by emitted flux. So this is the flux on this surface, in this case the 1155 lumens, divided by the total flux emitted by the sources, and in effect its efficiency. So this assembly is just a little bit over 87% efficient and getting light onto this desktop from the LEDs that are mounted up in the reflector. Now, another option here, we may want to look at the angular distribution. So again, with that surface selected, I'm going to go up to Analysis, Candela Plots, and I'm going to choose a polar candela distribution. And same thing here, I'm going to right-click and choose the options. And for my ray selection here in the middle, I want to choose incident rays from that selected surface. So I want to see the rays that are hitting that target. And then I'm going to come over here to the last tab, Candela Distributions. I haven't traced a lot of rays, so I'm going to turn on smoothing. And I'm going to change the number of horizontal angles to 2. And lastly, set it in a luminaire format. And then click Apply. And here's the angular distribution of the light hitting that target from that lamp. And in effect, it shows two profiles, a 0 and 90 degree. So you could think of it almost as horizontal and vertical profile or X and Y profiles. And it is pretty symmetric. I think if I ran more rays, I would get much more symmetric. And that's to be expected. It's a rotationally symmetric device. One quick note here, if you're working with IES files, say you want to transfer this to an architectural lighting program, you can do a right-click, choose Save As, and then you have the option of saving it as an IES or an LDT format, a LUMDAT. So very easy to then create IES files right from your TracePro models. And lastly here, I just want to show a different type of irradiance illuminance map. So I'm going to turn the rays off. And when you turn ray display off in TracePro, they're still there. All the results are still there. It's turning off the display of the rays. But I could come up here and I could go to Analysis, 3D Irradiance. And this is going to show it right on the surface in the model. Here's my target. And again, it's rather coarse. So I'm going to do a right click, choose the options, turn on smoothing, and I'm going to increase the number of pixels. I'm going to change the color palette as well. And things like color palette are more personal preference. We have several options available in the program. I also want to change, before I do the next step, I'm going to change it to a log scale. But what I can also do here is I'm just going to turn on the Surface Select tool, hold down the Control key, and I'm going to click a few other surfaces here. And you can see, we can now see the irradiance data, or the illuminance data in this case, on multiple surfaces in the model. So we could go through on any surface here and start to see illuminance data on that surface. So a very useful tool for seeing the lighting patterns right in the model itself. And you can see here, we're in Lux. If I went back to Ray Trace Options, and then the Options tab, I could change to radiometric, and now without even having to rerun the ray trace, my results are in watts per meter squared. I did make a quick note about octree settings before we ran that ray trace, and that's done here in this last tab, Advanced. And we can change the type of voxels from uniform to octree. Okay, so that sort of wraps up a quick walk through a luminaire example. What I want to do now is I'm going to go back to my notes, and I'll show you what we could do for a backlight or a light guide example. Here's a light guide. This is the finished model showing, again, the 3D irradiance illuminance. In this case, it's illuminance because we're showing lux, visible light. And this is a little light guide. It has an LED at each end here, and a couple cutouts. And we'll walk through the setting this up. We'll apply a material property to the light guide. We'll apply a surface property to the target. In this case, the target's named receiver, or the surface named receiver of that target. And also show you quickly how to use or how to apply a reptile property. Reptile is a way of modeling repetitive microstructures. And in this example, they're little half millimeter radius hemispheres that are used as light extractors. So they break the TIR in the light guide and direct the light towards the target or the user. And you can vary the distribution of those around the surface to eventually try to produce uniform illumination. And one quick note on Reptile, it is only available in the Expert edition of TracePro. So it is one of those features that shows up in TracePro Expert, but very useful feature when you're doing light guides and backlight displays. We're going to use ray files in this example, and we'll use them as file sources in TracePro to model the LEDs. So we'll insert one ray file here at the top. We'll insert another one here at the bottom. We'll once again set our analysis units to photometric, run through the ray trace, and then take a look at the results. Here's the illuminance on the receiver, and then again the 3D illuminance. So let me show you how easy that is to set up. I'm going to come in here and I'm going to open up the model. In this case, this model was made using the 3D Interactive Optimizer in TracePro to generate the shape. I wasn't actually optimizing the shape. I just used some of the tools in the optimizer to create this shape. And very easy, this could have been brought in from SolidWorks or Pro-E or any other program like that as well. So first step, one quick mention before I do it. This model has a couple little objects here to represent the LEDs, but in this case, you can see they're turned off. They're not going to be used as part of the ray trace. They're really there as a visual representation only. So my first step, I'm going to select the light guide, right-click, choose Properties. I'm going to choose Material, and I'm going to go to the Plastic catalog here, and then I'm going to select PMMA. And so far, every property I've applied during this demo are part of the standard TracePro database. There's no custom properties at this point. I'm going to apply that. I'm going to keep this dialog open. I'm going to go to Target, select Receiver. So this is my surface where I'm interested in seeing the results. Switch to Surface Property. And then from the default catalog, once again, we're going to choose Perfect Absorber. Okay. Now the bottom of this light guide, it's this surface here that's highlighted. That's where I'm going to apply the texture that's going to serve to extract the light, break TIR. So I'm going to do that using Reptile. I'm going to right-click, go to Properties, and I'm going to choose Reptile. Remembering, again, this is a feature in TracePro Expert, so not all editions have this capability. And for the first time, I'm also going to use a property that's a custom-made property. So I'm going to go up to a folder here I have named Backlight Optimization and choose a property named Backlight Texture. In this example, I used the Texture Optimizer 2 in TracePro to automatically optimize the distribution and the density of those dots to produce the best illumination possible. So it's another utility that's built into TracePro that lets you do that. It'll automatically go through, vary the density of the dots, and produce the best result that it can. I'm planning on doing a webinar on the Texture Optimizer 2 probably within the next month or two. So anybody that's interested in that, please keep your eyes open. We'll be setting that webinar up soon. Now we also have with Reptile the ability to apply a surface property to that Reptile feature. Now, as I mentioned, these features in this case are 0.5 millimeter radius or 0.5 millimeter high hemispheres. And I'm going to apply a flat white paint to those. So think of this if we have all these little hemispherical dots applied to that, and each one of those we put a drop of white paint to fill it in. I can pick how I'm going to apply this Reptile. What are the boundaries of it? I can do circular, rectangular, or there's an option here called Use Surface Bounds. And Use Surface Bounds will take the shape of this surface here in the model, this highlighted surface, and use that as the boundary for the Reptile. This is a relatively new feature in TracePro, but it gives you the ability to apply Reptile to oddly shaped profiles. If you remember, I just mentioned my hemisphere is 0.5 millimeter high, so I'm going to set the depth at 0.5 millimeters, and then click Apply. Just pops up, says it's updated some of the settings. Click OK. I can close this. And if I come here to the bottom surface, expand it, it says backlight texture for the Reptile surface. Now, by default, TracePro does not show you the Reptile property or the reptiles, but I can display them by going to View, Display Reptiles, Reptiles and Boundary. And here we see the distribution of those little 0.5 millimeter hemispheres. As you can see, the LED is here and here. As you get further away from the LED and around these bends, we see a higher concentration of the features. So you need more features to extract the light the further away you get. And that's the way it controls the uniformity across that. The more features, the higher the density, the better the extraction. So it's balancing here where it's easier to get light out than here where there's less light to extract. And then last step, I'm going to turn off the display of the reptiles. Last step here is we want to set up the sources. I want to have an LED here and an LED here. And I'm going to use ray files for this. And in TracePro, we use ray files as file sources. So I'm going to go to Define, File Source. And the first thing I'm going to give it a name, LED1. Now I can browse to where I've saved the ray file. So I'm going to click here. And I already have one downloaded. In this case, it's an Osram LWW5AM ray file. So for a white LED, these are the yellow wavelengths, and it has 100,000 rays. And I'm going to click Open. Now, most manufacturers make the LED ray files available on their websites. So whether it's Osram or Cree or Nichia or Bridgelux, any of these manufacturers, you can go to the documentation or the support section and download these ray files. And the ray files are great because they're made based on measured LEDs. So they take into account all of the properties of the LED. So what are the materials, what are the shapes, the geometries, the surface finishes, things like that. And it lets you insert it without actually having to build anything of a model. One thing too, when you do download ray files, is just make sure you're downloading the TracePro format for the ray files. Now, typically ray files are defined at the origin 0, with a rotation so that the rays go along the z-axis. And that's not where we want to use them here. We actually want to put one here going down the negative y-axis and one here going up the positive y. So I can use the center position here to change that. And I know just from previous, the values I want to use are x is 0, y is 75.5, and z is 2.5. And my rotation is I don't want the rays going left to right here. I want them going top down. It means I need to rotate 90 degrees about the x-axis. I'm going to click Insert. If I come over to the Source tab, we can see I now have LED 1 added in as a file source. We can see this little red wireframe sphere up here. Represents the boundary of where the rays are coming from. Now, without closing this dialog box, I can actually come in, change the name to LED2. I'm going to change my Y position to -75.5 and change my rotation angle by 180 degrees so that the rays for this one are now going to go from down to up. And then click Insert. And I now have two LED ray files defined in this model. One going down this way, one going up that way. And then last step, run the ray trace. And I should mention as well as this is going on, TracePro is a multi-threaded program. So the more processors you have, the faster the ray trace will run. It's also 64-bit compatible, so it lets you use as much RAM as you have on your computer. As of TracePro 7.6, I believe, TracePro is only 64-bit. We no longer offer the 32-bit version. Okay, this was telling me I had one ray escaped the reptile boundary, and one ray out of 200,000 I'm not going to worry too much about. It also told me my ray drawing limit's been exceeded. I have my, the default setting in TracePro is to only spend 1 second drawing rays. Anything beyond that, it doesn't draw them, but it does compute the results accurately. It's just how long is it's going to try to spend drawing rays. And you can change that setting if you wanted to draw more. First thing to clean this up again, I'm going to go to Target and Receiver. I'm going to go to Analysis, Ray Sorting, and once again, Selected Surface. So this is going to show just the rays hitting my target surface. I could come in and look at the irradiance map, so under the Analysis menu, with the surface named Receiver selected. There's my illuminance map. We can see not a bad job. It's fairly uniform. There are some hot spots around here and around where the LEDs, so might be worth going in, making some changes to the model to try to fix that. We could also look, I'm going to turn the ray display off for this. I could go to Analysis, 3D Irradiance, and I'm going to change. I've been in render mode so far. I'm going to change under View to Silhouettes. Just makes this a little easier to see. But there's the 3D irradiance map right on the surfaces in the model. So a great tool for seeing things and visualizing it right in the model space itself. So that's sort of a quick way. You could also now set up and do a luminaire, a backlight or a light guide analysis. So that's really going to finish up for today's webinar. Just a quick summary of what we've looked at. Hoped was able to show you that TracePro is easy to learn and use, and it's going to allow you to quickly get up to speed with analyzing and ultimately improving your designs. The design process using a tool like TracePro can be shortened considerably. It also allows you to design and test your designs virtually, cutting down on the need for physical prototypes. What I like to say is it lets you make your mistakes in software as opposed to hardware. Much easier to fix, much faster, and much cheaper to do it in software than it is to be making prototypes, analyzing them, measuring them, remaking, redesigning. So it can really speed up that process. Models can be imported from CAD programs or built directly in TracePro, you don't necessarily need a CAD program. There's also numerous analysis tools available, things like the irradiance and illuminance maps, the candela plots. There's luminance plots in TracePro as well, and photorealistic rendering, and a lot of other tools. And that this analysis process is easy and very straightforward. And lastly, we've tried to provide a logical and organized menu structure that lets you sort of build a consistent workflow and really sort of speed the process. You're not looking for buried items in menus. For anybody that's not a TracePro user, we do offer a free 30-day trial, and you can sign up for that at our website, www.lambdares.com. I've been mentioning webinars as we go along, past webinars. Those are also all available on our website. And please feel free to give us a call, 978-486-0766 here in the US, or send us an email at sales@lambdares.com, and we'll be happy to answer any questions you may have. I'll also comment here before we get into the questions is we are recording this webinar, so we will be putting a copy of this recording up on our website, and it will probably be up within the next day or so. So again, it'll be in that webinar section on our website. With that, I'm going to bring Mike back in. Looks like we have a couple questions, but also like to remind people, if you have any questions, please feel free to use the question box in the GoToWebinar control panel, and we can answer those questions here.
Well, Dave, thank you for putting that whole webinar together for us and all the slides. And yes, we will have them up tomorrow. We do have a couple questions here. The first one's from Sean.
Yeah.
Are the hemispheres raised or below the base surface of the receiver in your reptile example?
You have the option of either way. In this case, these are done as holes. And what I'll do is I'm going to turn the reptile display on here. And I'm going to zoom in. It's a little hard to see because they're all sort of overlapping here, but these are holes. So these are hemispherical dimples, in effect, sort of like a golf ball. You could change that to what's called the bump, which would then turn that around so they would be sort of proud of the surface. Hopefully that answers that.
We also had a question this morning that was quite interesting. Are you able to show the illuminance on multiple objects, for instance, on both the window in the desk lamp example, and at the same time the desktop, and maybe some of the structure as well? I know you showed some of that, but you didn't. I don't know if you flipped this around and showed how you would do it at the window as well in the system tree.
Right. Well, you could do basically the 3D illuminance will work on any surfaces we have selected. So, for example, if I turn it off, I'm going to come back, turn it back on, and I can turn on my surface select tool. And it's just a matter of coming in and picking the surfaces where you want to see the results. Now, also the question this morning was also somebody was interested in the light hitting the glass here. That's a good question. So I could pick the glass surface. Now, by default, it doesn't show anything. And the reason for that is that the glass doesn't have any absorption or very little absorption. And the default setting for this, in this case, irradiance, because I left my units in watts per meter squared, the default setting is for absorbed flux. So I'm going to right click and choose the options. And I'm going to change the raise to plot to incident as opposed to absorbed. I'm also going to change down to take the log scale off. So here we see the light that's incident on this piece of glass here. This is light that's going to be hitting that and then eventually coming down through this lens, or if in a diffuser if we wanted to, and then eventually getting to the target. So the only real, I won't say trick, but the only thing to note there is that because it was a piece of glass with either no or very little absorption, we wanted to change that raise to plot from absorbed to incident. So if you remember that TracePro by default plots absorbed rays or absorbed flux as opposed to incident. That's why sometimes your irradiance or illuminance maps may show up blank.
Well, Dave, I think that's all in terms of questions. Once again, thanks for putting this together for us. Is there any other comments you wanted to make?
No, I think that's about it. I hope everybody enjoyed this and hopefully learned something today. Just trying to emphasize the point that it's the process in TracePro is very straightforward, very easy to learn, and you can very quickly get up to speed and start showing results. And again, anybody has any questions, please feel free, send us an email here, sales@lambda.res, and we'll be happy to answer any questions you may have. And look forward to seeing everybody at our next webinar. So I think that's it for me. Anything left for anything for yourself, Mike?
No, I think we're done. I guess we're going to wrap it up right now.
Okay. Again, thanks everybody for attending, and we will talk to you soon. Have a good day.